We are from Welltech Multitech Dr. Rankarajan, Dr. Sakundala Engineering College, and from EC department. Our project title is Cartoon Texture Image Decomposition using Alternating Direction Method of Multipliers. I am Neetu, and my batchmates are K. Nitya Kalyani, B. Akila Priyadarshini. We are going to introduce an image decomposition method, whereas we are just going to decompose our image into two components. One is cartoon and another one is texture. Generally, an image consists of two components, that is cartoon. Cartoon is nothing but your piecewise smooth part of an image, and texture is nothing is locally patterned oscillating part. Okay, and we are going to propose this as we are going to decompose by BNN and ADM technique. This is the existing method, total variation method. In this total variation, it worked well for cartoon component alone, but we can't extract for texture component, so that we are moving on to our proposed work. Then another technique is genome technique. In this, many mathematical calculations are there, so that it gives you more complexity. That is the main disadvantage. Our proposed model is based on blockwise manner. Texture is generally known as globally dissimilar, but it is locally well patterned. The texture components is considered as the sum of subtextures, each of which is considered by BNN. BNN is nothing but block nuclear norm. Cartoon component is extracted by TV method, and then the texture undergoes the ADMM method. ADMM is nothing but alternating direction method of multipliers. Then the convex optimization algorithm is also used here. The image is decomposed by ADMM method, which recovers our lost pixels, because while applying TV method, many useful information can be lost. And steps involved: first we are going to acquire an image and test pre-processing. Pre-processing is nothing but we are removing our noise, and then we are going to segment our image into cartoon and texture component. First of all, first step is to acquire an image, which we have to decompose into cartoon and texture components. Then based on our concept, we have to choose our blockwise and shift step. For blockwise means block nuclear norm. So we are going to choose our blockwise. Next is to choose shear angles. Shear angles is nothing but we are going to obtain our textures in different direction. That's what we are calling as alternating direction method. Okay. Then the difference operators are used to remove noises. Shear operators are used to separate images as blockwise and analyze it in different angles. Here the observation operators are used to identify the block differences ECD. Then considering average constant and splitting cartoon and texture components. After attaining number of iterations, the main program is processed. Then checking our PSNR value and SSIM value of the image. Finally plotting the resultant cartoon and image separately. This is a sample output. This will be your input image, then cartoon, and this will be your texture. This will be your subtextures. Subtextures are nothing but we are extracting our textures in different angles. This will be, we are taking here, it will be 0 to 45 degrees, so that these are the subtextures. Advantages: in genome technique, denoising algorithm sometimes considers normal image pixels as noise pixels and remove them. Whereas ADMM algorithm overcomes this disadvantage. Denoising in ADMM is a pre-processing step while decomposing. Applications will be face texture identification, fingerprint recognition, pattern recognition. Then we are moving on to simulation. We are using here software will be MATLAB, version will be 2007, and this will be our main program. Here we are acquiring a file and then applying our proposed model. Then run. Our ADMM is running here. The processes will be: we are acquiring an image, and difference operators will remove your noise, and periodically expanding operators will expand your image. And this will be our output. This will be the input image, and we are separating this as cartoon and texture components. This will be the resultant image, which is nothing but we are combining this cartoon and texture component, that is without noise. And original image will be before transmission of the image, so that we are getting SSIM as 1. SSIM is nothing but similarity, structural similarity index module. It should be 1. So that is, there is no difference between your original image and our resultant image. And PSNR will be 71.34. We are increasing PSNR by 50 to 70 ranges. That's it. We are concluding our project. Thank you.